Hi, in this video, let's work out a few very basic and easy problems that use this algebra of limits. Let's quickly go over the limit laws. So here are the limit laws that I introduced you to in another video. So let's look at an example now. Let's look at this very easy example. Suppose we are given this information about three functions f, g, and h. Namely, their behavior very close to the point 2 on the x-axis. So here, limit of f of x as x approaches 2 is 4, limit of g of x as x approaches 2 is -1, limit of h of x as x approaches 2 is 10. So we don't have information about the graph of those functions or a formula for those functions. All we have is this behavior of the function for values of x very close to 2. We're given information about the two-sided limits. And now we would like to compute the limit as x approaches 2 of this function, that a new function created out of these three old functions, f of x plus 3 times g of x plus h of x. And the limit laws will help you with that. Here we have a sum of three functions, and you know from one of the limit laws that it's okay to calculate individual limits and then add them up. That's what this step tells you. And now here again, what you notice is that limit of 3 is a constant number, constant times a function. Again, another limit law will tell you we can actually drag the 3 outside of that limit. So when you do that, what you end up with getting is limit of f of x as x approaches 2, you're given is 4. This is simply same as 3 times the limit of g of x as x approaches 2, and so that's 3 times -1. This is same as this, 10, and you can do the simple calculation and you can get your answer. So this is one easy example that uses the limit laws. Let's look at another example now. So for this example, notice that the limit of f of x as x approaches 2 is 0, limit of g of x as x approaches 2 is also 0, and limit of h of x as x approaches 2 is 10. And I would like to calculate the limit of this new function, which is h of x cubed as x approaches 2. As you know, h of x cubed, that's really same as h of x times h of x times h of x. And now we have limit of a product of a bunch of functions by one of the limit laws. Even though I stated the limit law only for product of two functions, you can generalize it to the product of any number of functions. If you apply that, then this is same as taking the limit of h of x as x approaches 2 and multiplying that number by itself 3 times. So that's how I get 10 cubed. And so we use the limit laws to calculate this limit. Now let's look at these two limits. Limit of h of x over f of x as x approaches 2, limit of f of x over g of x as x approaches 2. So it's tempting to simply compute the limit of the numerator, limit of the denominator, and take the ratio of those two numbers. Except here, notice the limit of f of x is actually 0. So you cannot use the limit law when the limit of the denominator is 0. So for this one, we cannot apply the limit law. Keep that in mind. Similarly, for this situation too, we cannot apply the limit law for the same reason. So keep that in mind. In a future video, you'll see that for this scenario, where the limit of the numerator is a constant number, but the limit of the denominator is the one that's 0, we will see such a limit does not exist. We'll postpone the discussion to another video. And in a scenario like this, where the limit of the numerator is 0, limit of the denominator is 0, we'll postpone the discussion to another video, where we will actually have formulas for f of x, formulas for g of x. And for this scenario, you'll see that we'll need to do some algebraic manipulations or use some other tools to figure out this kind of a limit. Right away, we are not able to conclude this limit does not exist, as I said would be the case for number 2. So we'll postpone number 2 and number 3 type of problems for another video. For now, it suffices to know that we cannot apply the limit law stated for quotients that we just went over. So these examples need further discussion. Thank you.